On July 1st, 2025, a cosmic intruder crashed the solar system's party, and it's been turning heads ever since. Meet 3I/ATLAS, the third interstellar object ever spotted in our cosmic backyard, and it's not playing by the rules. Moving at a blistering 60 kilometers per second, fast enough to escape the sun's gravitational grip forever, this massive comet, potentially 7 miles wide, is rewriting what we thought we knew about how comets behave. Its orbit has shifted in ways that gravity, gas jets, and even sunlight can't fully explain. Imagine a heavyweight boxer dodging punches with the agility of a featherweight. It shouldn't happen, yet here we are watching 3I/ATLAS defy the cosmic rulebook right in front of humanity's best telescopes. So, what's driving this interstellar rebel, and what does it mean for our understanding of the universe? Buckle up, because this is a story of mystery, discovery, and a universe that loves to keep us guessing. If you're as curious as I am about what's out there, hit that subscribe button and let's dive into the enigma of 3I/ATLAS together. Let's set the stage. Comets are the solar system's wanderers, chunks of ice and rock that heat up as they approach the sun, releasing gas and dust in a glowing halo called a coma. This outgassing can act like tiny rocket thrusters, nudging comets off their predicted paths. For decades, astronomers have relied on this playbook to predict comet motion. The Rosetta mission to Comet 67P/Churyumov-Gerasimenko, for instance, showed us how gas jets from just 10% of a comet's surface could spin it faster or nudge it off course by thousands of kilometers over time. The math is straightforward. Measure the gas output, factor in the comet's mass, and you can predict its trajectory. For a typical comet, water ice is the star of the show, vaporizing into jets that push the comet around. A small, lightweight comet is easy to budge, but a massive one? That's like trying to steer a mountain with a leaf blower. And 3I/ATLAS is no lightweight. Estimates suggest its nucleus could be 3 to 7 miles across, comparable to Halley's Comet, a giant by comet standards. Yet, this behemoth is veering off its expected path in ways that have astronomers scratching their heads. The discovery of 3I/ATLAS was a moment of pure serendipity. On that fateful July day, the Asteroid Terrestrial Impact Last Alert System, or ATLAS, spotted a faint speck moving far too fast to belong to our solar system. Its speed, nearly 130,000 miles per hour, marked it as an interstellar visitor unbound by the sun's gravity. Only two other objects, 1I/Oumuamua in 2017 and 2I/Borisov in 2019, have ever earned that title. But 3I/ATLAS is different. Its orbit is almost a straight shot through our solar system, with an eccentricity of 6.141, wildly high compared to the elliptical orbits of local comets. For context, an eccentricity above 1 means an object is on a hyperbolic path, destined to leave and never return. 3I/ATLAS's trajectory is so extreme it's practically a cosmic flyby. Within hours of its discovery, telescopes worldwide, from Hubble to the Very Large Telescope in Chile, turned their gazes to this intruder. What they found was a comet unlike any other, with a chemical makeup and behavior that challenge everything we thought we knew. Let's talk about that chemistry, because it's where things get really weird. The James Webb Space Telescope, with its near-infrared spectrograph, peered into 3I/ATLAS's coma on August 6th, 2025, and what it saw was jaw-dropping. For every molecule of water vapor, there were 8 molecules of carbon dioxide, a CO2 to H2O ratio of 8:1. The highest ever recorded in a comet. Most solar system comets are water-dominated, with carbon dioxide playing a supporting role. Here, CO2 is the star, pouring off the nucleus at 70 kilograms per second, while water trails at just 4.5 kilograms per second. That's not just unusual, it's a statistical outlier, 4.4 sigma above the norm for comets at this distance from the sun. To put it in perspective, it's like finding a cake made mostly of frosting instead of batter. This chemical quirk hints at where 3I/ATLAS might have formed. possibly near the CO2 ice line in its parent star's protoplanetary disk, where carbon dioxide freezes while water stays gaseous. Or maybe it's been cooked by cosmic rays over billions of years, altering its surface chemistry. Whatever the cause, this comet is telling us a story of a very different birthplace. But the chemistry doesn't stop there. The Very Large Telescope in Chile picked up something even stranger: 22 distinct emission lines from atomic nickel, but no iron. In most cosmic objects, nickel and iron are like cosmic buddies, forged together in supernovae and found side by side in meteorites. Yet 3I/ATLAS is pumping out nickel at a rate of 4.7 times 10 to the 22nd atoms per second, with iron conspicuously absent. Scientists think this could be due to exotic organometallic compounds or nanograins breaking down under solar heat, releasing nickel in a way we've never seen before. This isn't just a chemical curiosity, it's a clue to the comet's history and the conditions it endured on its long journey through interstellar space. Add to that the detection of cyanide gas and carbonyl sulfide, and you've got a comet that's practically shouting, "I'm not from around here!" These findings, published in a preprint on RxShiv by Martin Cordiner and colleagues, are shaking up our understanding of what interstellar objects can be. Now, let's get to the heart of the mystery: that orbital shift. When astronomers plot 3I/ATLAS's path, they expect a clean, predictable arc based on gravity, solar radiation, and outgassing. But the data tells a different story. The comet's actual position diverges from predictions, not randomly, but systematically, across observations from multiple observatories. These residuals, the gaps between where the comet should be and where it is, are small but persistent, refusing to align with standard models. For a typical comet, gas jets explain such deviations. But for 3I/ATLAS, the numbers don't add up. Even with its massive CO2 output, the force from outgassing is too weak to move a nucleus this large, potentially billions of tons, by the observed amount. It's like trying to push a freight train with a bicycle. The dust output, measured by Hubble at 12 to 120 kilograms per second, isn't enough either. Something else is at play, and it's forcing astronomers to rethink the playbook. This isn't the first time an interstellar object has pulled a fast one on us. Cast your mind back to 2017 when one ʻOumuamua streaked through our solar system. Barely 400 meters long, it was a cigar-shaped oddity with no visible coma or tail. Yet, it too showed a slight acceleration, about 17 millimeters per second squared, that gravity and standard forces couldn't explain. No jets, no dust, just a mysterious nudge. Theories ranged from invisible hydrogen outgassing to solar radiation pressure, but no explanation fully closed the gap. Some, like Harvard's Avi Loeb, even dared to suggest it might be an artificial object, a solar sail from another civilization. The idea was controversial, to put it mildly, but it highlighted a key point. When the usual answers fail, the mind starts reaching for the extraordinary. With 3I/ATLAS, we're seeing echoes of that mystery, but on a much grander scale. Its sheer size makes the deviation even harder to explain. If Oumuamua was a whisper, 3I/ATLAS is a shout. So, what's causing this orbital anomaly? Let's explore the possibilities, starting with the most grounded. One idea is fragmentation. A crack in the nucleus could shift its center of mass, altering its path. But there's no evidence of a major breakup in the images from Hubble or JWST. Another theory suggests the nucleus might be less dense than assumed, perhaps a loose rubble pile rather than a solid rock. A less dense object would be easier to nudge, but the coma's chemistry and the comet's brightness suggest a compact, icy core, not a fluffy pile of debris. Then there's the CO2 itself. Its high volatility means it sublimates farther from the sun than water, potentially driving early activity. But even at 70 kilograms per second, the force is too small to account for the drift. Scientists have crunched the numbers, and the momentum budget comes up short every time. It's like trying to solve a puzzle with a missing piece. This brings us to the wild card, the kind of idea that makes scientists squirm but keeps the public buzzing. Could 3I/ATLAS be something more than a natural comet? Avi Loeb, never one to shy away from bold hypotheses, has suggested that interstellar objects like Oumuamua and now 3I/ATLAS might carry signatures of artificial design. In a 2023 paper, he proposed that a lightweight, ultra-thin solar sail could explain Oumuamua's acceleration. For 3I/ATLAS, the math is trickier. Its massive size demands a far greater force. But if it were hollow or engineered with an enormous surface area, a sail-like structure could, in theory, harness sunlight to produce the observed shift. Let's be clear. There's no evidence that 3I/ATLAS is an alien probe. The mainstream view is that it's a natural object, shaped by processes we don't yet fully understand. But the fact that such ideas are even on the table shows how far this comet is pushing our models. When nature defies explanation, it opens the door to speculation. Let's zoom out for a moment and think about why this matters. Interstellar objects like 3I/ATLAS are time capsules forged in the crucibles of distant stars billions of years ago. They're not just rocks, they're archives of cosmic history. By studying them, we learn about the building blocks of planets, the chemistry of star systems, and maybe even the conditions that could support life elsewhere. 3I/ATLAS's closest approach to the Sun, on October 29, 2025, at 1.36 astronomical units, will be a critical moment. As it heats up, its outgassing could intensify, revealing more about its composition. But it'll be hidden behind the Sun's glare from Earth's perspective, so spacecraft like ESA's JUICE or NASA's Parker Solar Probe might catch a glimpse. When it re-emerges in December, astronomers will be ready, hoping to capture every last detail before it fades into the cosmic void. The human side of this story is just as compelling. Imagine being Bryce Bolin, a research scientist at Eureka Scientific, who studied all three known interstellar objects. He described the moment of 3I/ATLAS's discovery as electrifying, a rare chance to glimpse a visitor from another star. Or picture Marco Micheli at ESA's Near-Earth Object Coordination Center, meticulously calculating the comet's trajectory to ensure JWST's tiny field of view could capture it. These scientists are racing against time, knowing 3I/ATLAS will never return. Their work isn't just about data. It's about chasing the unknown, fueled by a passion to understand our place in the universe. Their stories remind us that science is a human endeavor, driven by curiosity and persistence in the face of mystery. As we wrap up, let's reflect on what 3I/ATLAS is teaching us. This interstellar giant, with its bizarre chemistry and defiant orbit, is a reminder that the universe is full of surprises. It's not just breaking the rules, it's showing us the rulebook was never complete. From its CO2-rich coma to its nickel emissions, it's a snapshot of a distant world, shaped by forces we're only beginning to understand. And that orbital shift? It's a challenge, a puzzle that demands we rethink how we model the cosmos. As the Vera C. Rubin Observatory prepares to flood us with new discoveries, we're on the cusp of a new era in astronomy. 3I/ATLAS is just the beginning, a cosmic curveball that's forcing us to swing harder and aim higher. So what do you think 3I/ATLAS is hiding? Is it just a weird comet or something more? Drop your thoughts in the comments, hit that subscribe button, and let's keep exploring the universe together. The next interstellar visitor is out there, waiting to surprise us again.